Shaper Tools is proud to introduce Humboldt. So this is our latest software release, the H release. We're going in alphabetical order, and it's a huge improvement to Origin. In every release, we focus on performance improvements, tuning things, and this is no exception. So in this release, we have looked at dense files, so heavy in terms of data, a lot of geometry, and we've made them cut a lot more efficiently. So when you're placing and cutting these files, Origin will behave a lot more fluidly and will feel a lot more responsive. So you'll get better outcomes. It'll be a lot more enjoyable to cut these files. We've made usability improvements across the board, lots of little tweaks. We'll go into a few of them in detail here. But the big focus here is the workstation. We've released the hardware product, the Shaper Workstation, which enables you to fixture geometry, awkward geometry, quickly, accurately, and repeatably, meaning that you can have a reduced burden, a reduced friction to setting up a job and getting cutting. You just clamp it to the workstation and you know you're getting 90 degrees, dead flat with your tape plane along the top, and you can just start cutting immediately. We've taken that and built upon that with our suite of software. For instance, we've gone and taken Grid and made it a lot more flexible, a lot more adaptable, and a lot more intuitive to use. So our user interface communicates exactly what state you're in as you go, and you can make decisions to intelligently select exactly how you want to create a grid. We'll describe that in a little bit. And workspaces themselves have been overhauled. So workspaces can now be renamed, duplicated, deleted, searched. It's had a massive amount of attention focused on it, which means that now the workstation will be an integral part of Origin and vice versa. You'll see the two working really strongly together to get you efficient, accurate, and less of a burden thinking about what you're doing when you're working on a job. You're just intuitively working with your hands, and Origin's there to help. Now we'll move right along to Grid. Grid has received a huge amount of attention. That's a big part of supporting the workstation. So what is Grid? Why does it matter? And how can we take advantage of it? We'll run you through that from the ground up now. So to those unfamiliar with Origin, Origin tracks its position using a camera facing out the front. The only thing it's interested in is these markers. So these are pre-printed on a durable surface for the workstation, but if you're working on just a regular panel, you'll lay it down with tape. So you just space those out at about 4-inch centers, and they can end up anywhere on that surface. So when we scan with the camera, we stitch together all those random positioned markers, and we measure the distance between them. So at the end of that scan, what we have is called a workspace. And that enables Origin to track its position relative to tape in real time. So that's a big part of what gets us accurate position relative to the tape itself. The next step is Origin has no idea of where it is relative to the edge of stock. So often we're going to want to place a shape exactly, centered on the top or an inch in from these two edges. So the gridding process is taking effectively a grid, think of like gridding paper, and aligns it to an edge, two edges of this. So one edge will be the x-axis, one edge will be the y-axis. So we're trying to get a 0 point here with x parallel to this edge, running right along that edge, and y running along this edge. So it's basically just like applying grid paper to the corner of your object. Probe 1, probe 2, and then probe 3 for a perfectly aligned grid. So that enables us to place things in the right orientation and specific increments from each edge very easily. So to do that, we're going to take a cutter, insert it inside the spindle upside down, and use Origin's spindle mechanism and this perfectly round cylinder as a measuring device. So we're going to drop it down below the surface and then bring it up and lightly touch it against the edge of this stock in two locations to get a straight line. So the key there is a light touch. We don't want to push hard. We don't want to introduce any deflection. We don't want to squash our wood. Pressing too firmly will cause the mechanism to deflect, and it will cause your wood to kind of compress. So that will produce a poor quality grid. It will be slightly offset. So the key is to just come up very lightly, touch the edge. It's a precision measurement, keep that in mind. So just lightly touch and click probe, and then move over, lightly touch again, and we come around a corner to get our y-axis and probe there. From that point on, we have a clear reference at 0 along this face and 0 in y along this face. So we can then place elements relative to that position, so an inch in from either axis or in the center here, however you want to do it, and know that it's always going to be aligned. Its orientation and its position will be explicitly tied to this edge. So there's 4 different methods of gridding. There's the traditional physical probing method that we've seen. We'll walk you through that in a second. So this is the standard approach to gridding that we're all familiar with. It's just lightly touching the probe against the edge to define 2 90-degree surfaces. There's then a hybrid approach, so it's probe 2 points. You would use the cutter with a point, so the engraving cutter, and then raise the cutter up and then visually probe the point of the cutter itself hovering above an actual line. So you would confirm you're exactly aligned with the pencil mark and then probe using that approach. There's also the entirely visual approach. So if you had a chalk mark in the middle of a floor, you would probe 3 times with the point of an engraving cutter hovering just above the surface. So you would do the same thing using the center of the cutter as your reference point, looking at this, not the screen. And then there's a shortcut, which is just a double click to get you a fast grid at the very center of the cutter itself. And that's the 4 methods. So we'll go through them now. First things first, we'll place an engraving bit inside the spindle, collet upside down so that the cylindrical shank is exposed. And we'll use that perfectly 1/4 inch cylinder to do our precision probing. We'll take an engraving cutter, put it in upside down, and tightened up. So we'll go through the motions of creating some grids. First we'll start with the standard basic grid where we just physically probe these 3 positions as seen in the info screen. Come over to this point, I'll go grid, new grid, and then we'll lower it. So I'm just confirming I'm off the edge and that the cylinder is going to contact my stock as I move it inwards. So once I'm happy with that, I set depth. Then I'm going to quickly check the diameter of my cutter. That's represented on screen here. So this is a 1/4 inch cutter. Note if this is set to 1/2 inch, it'll be really large and you'll get inaccurate readings. It'll be offset. And then check the increments. So this is just the spacing dimension between grid increment lines. Now, this is actually just how it starts. You can always go back and modify a grid and change your increments without having to reprobe it. So it's actually powerful for spacing elements out. So I'm just going to bring origin forward, and you remember the cutter's down below the surface here. So it's very lightly physically contacting the surface. That's exactly what we want. We don't want to mash it against the surface. It's a precision measurement. I don't want any deflection. I don't want my wood getting squashed or anything getting me an inaccurate reading. I just want a very light touch, and then I hit the green button to probe the first point. You'll notice it moves on to the second point, and as I move, you'll see the line being drawn. So this is just showing me exactly what I'm creating. So if you're probing really close, it's not going to be as accurate as if you space it out. So I'm going to the far end here, and I'm going to probe again. Once again, very light touch against the stock, probe 2. And you'll notice this is auto. It's currently using the center. We'll get to that later. But as I round that second point, you'll notice it swaps automatically to the right-hand side of my probe. That's because it's anticipating we're going to come through here and do a standard probe against this edge. So I'm just going to touch it there and probe again. So now you'll see we have a grid perfectly aligned to our stock. I'll place a little rectangle just to show you why this matters. So we got 1 inch by 1 inch, done. Now I'm anchoring to the bottom left corner, which means I can come to this corner and snap it at 0, 0. So I know that that is going to be exactly aligned with that edge. I can also move around, I can be, and you'll see my dimensions are updating here. So I'm at 1.5 inches by 1.5 inches, and I can snap a shape there, or come back to 1/2 inch by 1/2 inch, whatever you like. But keep in mind that now the placement is exactly parallel to that X edge we probed. So we don't have to get worried about our orientation. That remains locked. So we've identified this corner. You'll notice if I hover down here, I'm at 0, 0. So that's perfectly aligned. I've identified the edge of my stock, and everything I do within this is now parallel or orthogonal to this grid I've created. So at 1/2 inch increments, I can go in and create a shape, 2 inch by 2 inch, 0.5 inch radius. Done. So if I wanted to come in and round this corner, I can just do this right here and go to cut, no offset, and make that an outside cut. So I could then just round that corner. I'll do an air cut just to show you what I mean. So that could round that corner very quickly and easily using grid and making the most of quite coarse grid increments. The same applies, if you're on a floor or something like that, there's a reasonable chance you're not going to want these tiny little grid spacing. So if you're wanting to place thing on, say, foot increments, the good news is I can go back here and go modify and set this to 6 inches. And now you'll see, if we zoom out, grid spacing is bigger than this object itself. But that would enable you to very quickly confirm you're aligned to 0, 0 on a large object. And then the opposite is also true. Grid modify. Once again, we don't have to reprobe or anything. We're just reusing that initial probing information and going in and changing the increment here. So I'm modifying this down to 0.18, and we'll zoom in again. So you'll see here, I'll erase my cuts and erase this old object, and I'll create a circle that's 0.125, and I'll place it at exactly 1/8 of an inch in from that corner. So you can see here how I'm jumping in 1/8 inch increments, and the anchor point is centered. You can see the value of modifying our grid increments and the fact that we don't need to re-grid whenever we do anything like that. So very powerful, very effective. So that's the standard gridding operation. Now we're going to look at a brand new approach where we can do things like start to probe the inside of this and then the outside and top. Basically any 90-degree element of stock we can now probe quickly and intuitively. You don't have to think too much about it. Grid, new grid. We'll leave the settings as is. I'm going to hover over the center, drop it down. Now ever so lightly touching it against the edge of my stock so that I don't introduce error. Set depth, and you'll notice here it's assuming I'm probing the top edge. Now we can override this and say, nope, I want to probe the bottom edge because we're touching the inside of that surface. So then I just go probe 1 and then move. I can go all the way to this far edge and then same again, very light touch. And you see my line is just confirming I'm accurately aligned there. Now, same thing happens. We're in auto mode here. It's assuming I'm probing on the left-hand side of the probe. I'm actually probing on the right, so I can override that as well. Centered, right. And once you override it, it remains locked. It doesn't try to automatically guess for you. So it's nice and should make things nice and quick for standard probes and leave the door open to adjusting for more non-standard probing arrangements. So probe the right-hand side, third probe. And now we have a grid aligned with this inside edge. So if I wanted to make a shape, say 1 inch by 1 inch, done. And then I use the anchor point, the far right. So I'm now creating a shape that's matching that inside edge. Or I can go outside that, you name it, anything in between. You'll see my grid updating based on my grid increment. So 0.5 snaps in both axes. Pretty powerful. So now we're going to come around and probe this outside edge and the top and show you that it's just exactly the same process. So I'm going to come out beyond the edge, lower my cutter. Once it's able to contact my surface ever so lightly to avoid inaccuracies, I'll accept the depth, and then I go probe once, and then I come up, probe again. It selected the right side of my probe, and then actually coming around the top has also selected the right side of my probe. So the first axis is technically X, and now I'm defining Y. So they're flipped 90 degrees, but it still enables me to place shapes, as we can see here, at very precise increments, very accurately aligned to the edge of my stock, and also oriented perfectly. I'm going to use the top right anchor point so that I can snap it to 0, 0 and know we're golden. Or snap it to any half-inch increment in this case. Or if I wanted to go in and modify my grid, I can use a different increment. So this identifies any 90-degree edge where we can physically probe the edges of the stock and places a grid very accurately aligned to that using the physical probing method. So now we're going to move on to a hybrid approach. So this will be our hybrid probing method where we do 2 physical probes and then a visual probe using the point of a cutter to reference this pencil mark. We're not going to use the screen scanned raster image of this that we see in our workspace. We're going to literally look at the tip of our cutter. So we'll go through the motions of that now. So we're going to place this sauce hinge, 204 sauce hinge, on a pencil line this way and halfway between this using our new gridding capabilities. So we'll start with the pencil line. I'm just going to approximately drop that in somewhere. So this is the 204 sauce hinge. We can download that on Shaper Hub. Right, so I've got the cutter with the point facing down here. I'm going to come over. Now the cool thing here is we actually have a cylindrical shank if we just go a little deeper than the cutter point itself. So I'll be using that for the first two physical probes, and then for the visual probe I'm going to raise up midway through and show you how to visually probe as well. We'll bring the cutter out beyond the edge. We don't want to mar our stock, and then go same as we have previously, new grid. Lower it down. We're going to move to the right hand side, and we're just going to make sure the cylindrical part of the cutter is down below the top edge of the surface. So we can confidently know we're measuring exactly using a cylinder. So set depth, same concept applies here. Very light pressure against the surface, and then that guarantees we get an accurate outcome. So I can feel it touch. I'm not pushing. Probe once. And then I'll move to the far end. You can see my line drawing. Spacing this out a good way helps you get accurate outcomes. And then probe again. Now what's really cool here is I can come back and change my depth. So this just brings me back to the raise option. And I'm going to move the cover and just hover over this line. I'm unplugged so I can rotate the cutter to a point where I can see if I just hover above the surface, and the subtle control of the depth. Perfect. So I can now see down here that I'm perfectly aligned, set depth, and auto, because I'm between those 2 points, automatically it's going to use a center probing option. I can override that, but I do want the center option. So I'm going to hit the probe button. Now I have a position where I can confidently place geometry relative to that edge and that pencil mark. So for things like door mortises, hinges, that sort of thing, that comes in really powerful to quickly know that you're 100% parallel to that edge and centered on that line. Next step is we'll measure this to 0.7. So I'm going to center it in this stock. So to identify the center point of this stock, we're just going to let Origin help us out here. With Grid Modify, I can create an increment that is half that dimension. So in this case, it's 0.7, so it's actually easy math divided by 2. We could just enter it, but if it was some pretty complicated decimal, it's nice to be able to do this. So I just divided that by 2, which means the center point here is exactly centered in my stock. Which means when I go import, I'm actually looking at my sauce hinge file. I'll load it in, and I'm using the anchor point that is centered. So accept that, place. So we're now super confident that this is centered between those two edges within the stock, and there's no orientation issues. It's always going to be exactly parallel. So I'm going to put my cutter in and cut this out. Now it's just a matter of entering the relevant depths. So my cutter diameter is correct. My depth, I want 0.25, done. So I'm cutting to the right depth, right cutter diameter. We've done a Z-touch. Double check my speeds. We're good. Let's go. So taking our sauce hinge, that drops straight in there, no force required, and that's a pretty delicate operation in some pretty soft wood that we get perfectly aligned to our pencil mark and centered in our stock. All, guaranteed orientation, alignment, and all the depth information for the nested pockets are contained in our file. The next example is using visual alignment. So we're going to be looking at a cutter, an engraving cutter inserted the normal way up. So the point is facing down, and we're going to use that point to align to pencil marks on a panel. So this doesn't make a lot of sense here, but if you're in the middle of a large floor and you've got a pencil mark that you want to align to, this gets us a really high level of accuracy. So I've scanned this in. I'm going to quickly find, on the screen I can see obviously my pencil mark. But to get it more accurate than what we see on the screen, we're going to, instead of touching probe against the edge, we're going to lower it down and observe it, hovering right above that pencil mark. So I've lowered it. Once I'm happy with the height, I hit accept, and then I choose the center option. So I'm not probing the top of the engraver, using the point, which is the center of the cutter. So now as I drag, I can quickly see on the screen that I'm vaguely correct, but I'm going to confirm I'm where I want to be by looking down at that cutter hovering above my pencil mark. Once I'm happy with that, I move back to the center, and I can see it's automatically switched to the center mode for my y-axis as well. Once I'm happy with that, visually looking at the point again, not the screen, hit accept, and we've got a perfectly aligned grid here. So for projects in the middle of a large area, that's really powerful. So now we're going to look at a shortcut that gets us very accurate grid aligned to a cross or a mark on a panel. But this particular one, we're going to use the orientation of origin itself. So if I hover above a point and just double click in the same location, it will use the orientation of origin for my x-axis, but it will be centered on the center of my cutter. So I'm going to do the same as I did in the previous one. Use an engraving cutter, lower it down until I'm satisfied that it aligns perfectly with a point down there, my pencil mark. Then I just hold everything still, double click the green button, and I get a grid that the 0, 0 point is exactly that point I referenced, and it's oriented relative to origin. So I mean, that makes sense for if you say just want to quickly place a circle or something like that. Something that the orientation doesn't matter, but the position is important. This is a cool one. We know a lot of people don't flip their cutter. Here we have a compression bit installed, and we're going to use it to use the cutting flutes for probing. So this is kind of a pro tip. In the past, the third click would just instantly start retracting when we completed our gridding. So now on the last click, we've made it so you can hold down the green button. It will complete the grid, and then you can move origin to the side, and it will retract when you release. So watching here, click and hold, move to the side, and then retract when I release. It's a really nice way of just avoiding scuffing the edge of your work. Another big performance boost that you get with the workstation is built into the fact that we always index into these same locations with the vertical alignment pins and machined front face of the workstation itself. So you can raise it up and actually grid against the workstation itself, and you can do that once. Then you don't need to rescan when you add stock that indexes against that face and the pins. So you can see we've got the 0, 0 point that's going to remain consistent as long as you are using the workstation. Then when you put in stock, even though you won't see the stock that you've just put in there, you can confidently place it at 0, 0 and then cut your shapes on it. If you want to see it, you can do an add to scan and you're good to go. To properly support the workstation, we've done a lot of work to workspaces. So what is a workspace and why do you care? So a workspace is basically what we see here. This is our scanned in raster image. You can see all the edges where the camera, what it saw when it was scanning. And then we have all the data for the tape. It's turned blue. We have a grid line running through it. Basically all of the files, say SVGs you've placed on CAD, everything's accumulated into what we call a workspace. So your cut history, you name it, it's all going into a workspace. So every time we scan, we create a new one. We'll go to the scan menu and show you. Up until now, these were all just named without the ability to manipulate it. So you would get, workspace 1, 2, 3, 4, 5, 6, 7. And it was difficult to stay on top of things, which the workstation makes that even more pronounced, right? So here we have all the visible workspaces. So this is every project that we've done on this workstation. And they all look quite similar because we're all using the same tape field. So we've gone in and added the ability, you see this one's called oval. So I can now go in here and rename this. So I'm going to click here and go rename. So oval 2. So this is my oval workspace. And what's cool about this is now I can quickly find it in a lineup. So even though I'm only looking at the currently visible workspaces, which there's 24 currently visible, we tell you how many results you get with each of these. And there's a total of 97 workspaces on this machine. So that's every time we've hit scan or add to scan, we've got a new workspace. But now we can do things like add to search here, and if I go oval, so as soon as I type OV, I'm down to one match. So now I'm confident I can hone in and find the project I'm looking for. If you have that word in all of your workspaces that are working on that project, you instantly can hone in with this search feature and find exactly what you're looking for. So that speeds that up. And the fact that we initially view only currently visible, that clears away a lot of clutter. So if you're looking at tape, you're only looking at what is currently relevant. There's a few more things here that are kind of cool. There's the standard sorting. So recently used, recently modified A to Z. So that should be pretty self-evident. We've looked at search. Now we're going to look at here. So this blue line shows me which one's active. I can then go in and just manipulate the naming as we've seen, or I can duplicate it. So let's say I'm working on my project and I want to get experimental. I want to try some ideas out. So I've duplicated this to copy, and I'm just going to rename that to, experiment. Done. So now I've got a file with experiment in the name, and I'm going to go in here and just start tooling around. So I'm just going to do some sort of destructive editing, test out some ideas, but I can do this now comfortable in the knowledge that I can always go back to that original file. So if I say go create basic text, add a C to this, done. I'm also going to scale this down to like 0.18, done, and we'll just snap that there. Delete the original. So this is now readily available for me to cut, but I can always go back using my workspace to the original. So they both exist now, and then I could take another permutation and adapt this. So that's a nice, way to lock down something you're happy with and continue to experiment. Beyond that, we have delete, but that pretty much rounds out our workspaces behavior. It's presented as simply as possible and should be pretty intuitive, but very powerful when you start using your own naming conventions and things. So we've improved the ability to seamlessly and intuitively switch between workspaces. So if you're performing a project that spans multiple different materials or different thicknesses, or maybe you're working collaboratively, we have now improved the way Origin moves between previously scanned tape fields, which is a workspace. So we're working on the workstation here. I've got a live job operating. I've scanned another panel. It was further away when I scanned it, but I've brought it close together so we can see how this behaves. So I've moved to the second panel, and it instantly shows me, hey, workspace 82 is available. And the green button's there to immediately return to the most recent workspace. If we return back to our workstation, you can see we have two options there, and the green button once again presents the most recent workspace that we were working on. Now the workstation has the same tape field for multiple workspaces. So that bottom option shows us all the scans that are currently visible with that tape field. So that's obviously going to be a few. So we can now select the one we want, use all the standard search tools, sorting, you name it. It's very flexible. If you're in a collaborative environment, you can see how you can just pass a tool back and forward and keep multiple people busy. But also if you just have projects running across different materials, this makes it very easy to move without having to navigate menus and things. So once again, green button returning to that workspace. So that's Workspaces. Very powerful when used in combination with your own naming conventions. You'll notice we don't enforce anything. You can use it however you like. But there's a few key features there that keep you productive and in command of your projects. Text Basic now includes all the characters you'll require to speak in French and German. You'll see a bunch of options here. Instead of being blank, all available for cutting with Origin. This one's subtle, but hopefully improves things, especially for like installing hardware and stuff like that, where you need annotations close by toolpaths. So the annotations being text and things, center lines in blue, they're guides, they're not cuttable. We've changed it so that they select last. If there's a toolpath available, that will highlight first. So it will now be easy to cut the shapes you wish to cut without getting guides and annotations being inadvertently selected. So we're always looking for faster ways to get people productive with Origin with less barriers, less friction. One of them is Vector. So it's a web-based package that lets you edit 2D vectors, create vectors from scratch. It's vectr.com. We don't create it or anything, but it is free and it's very easy and intuitive to use. So we'll link to a video with training information about how to get the most out of it. And the big takeaway here is you don't need to install anything. You literally just type in vectr.com, load it up, and you can start creating right in a web browser, and then save that file, drop it on ShaperHub, and you're up and running with Origin. So you can create accurately dimensioned files, color-coded, ready to cut. So hopefully that helps some people out, and we look forward to bringing you more capabilities in the future. That concludes our summary of Humboldt. I hope you see the value there. This should be a massive step up in a lot of areas. And for everyone who's ordered the workstation, we look forward to see how you use the two in combination, how much of an improvement it is to your workflows in your workshop.